Okay, this is problem 9 off the practice test, and this matrix describes the number of ways a person can fly city to city directly. It says explain how you could use matrices to find out the number of ways you can fly with one stop from city to city. Square this matrix is what you'll need to do. Specifically, we want to find out Washington to New York, so we need to square this matrix and find the value that's in the first row, third column, because that's Washington to New York. First row, third column after we square the matrix. So go to your matrix page, put in your values here, and copy and paste them here, or just retype them here. And the first row, third column is 5. So that's the number of ways that you can go from Washington to New York right here, 5. On the next problem, we have a rational function because there's a variable in the denominator, and it wants to know what does the horizontal asymptote mean. Well, let's see if it has one. So we go to the rational function page. And again, it is a rational function because there's a variable in the denominator. We put in our numerator. It was 3t minus 1, so 3 minus 1 here. There was no cubic or no squared term. The denominator, 0 for the cubic term, 2 for the squared term, 0 for the linear, and 5 for the constant, because the denominator was 2t squared plus 5. Put those in, and you don't even need to click a button. The horizontal asymptote's told to you automatically here. If you needed to find the x-intercept or vertical asymptotes, you would need to click this button. But the horizontal asymptote is at y equals 0, a height of 0. In other words, this means as time goes on, the concentration of medication is approaching 0. So let's go on to the next problem, and this gives you another rational function, 80,000 p over 100 minus p. So let's put that in. 80,000 is the linear term, and 0 constant, and then it was 100 is the constant on the denominator minus p. So minus 1 is the linear term, and remember there is no to make all your rest of them 0, like this one right here that just had a 2 in. For the squared term in the denominator, make that 0. Now this problem asks, let's see what it's asking. It says what is the cost approaching as a percentage of pollutants removed approach 100%. So we're putting in 100 in for p. Okay, putting in 100 in for p, and we can do that down here where we start the table. And if we start the table at 100, we get infinity at 100 because there's a vertical asymptote at 100. So what's the cost approaching? Infinity would be the answer to that problem. And if we would click on the button to find the vertical asymptotes, we would find that there's a vertical asymptote at 100. On problem 12, it gives you an exponential equation in a weird form. There's a constant at the end, and I ask you some questions about that. So this is an exponential equation again. So what we would do is go to our exponential sheet, and again this is an exponential equation where there's a constant at the end. So we need to scroll over to the right to get to this area. Put in your coefficients for a, b, and c, which I have in, and then it asks what is the value of the car at the time of purchase. We'll just start the table at 0, and you get 22,000. Then the next problem asks how long until it's worth half its value. Well, half of 22,000 is 11,000, so put 11,000 here, and you get 3.71 years. And then it also asks what does the cost level off to? Well, this function does have a horizontal asymptote at 1,000, so the value is leveling off to $1,000. This is not a height of 0. This is a height of 1,000 right there. And that would be the answer to all of problems 12 questions. And then the last problem, or next to last problem on the practice test, says make a graph for the situations, describe what type of function you would use. The amount of money, so in part A it says the amount of money you have in a bank that gives a set interest rate. Well, interest rate compounded, it grows exponentially. So this is exponential growth. Your x-axis is time, your y value is amount, and it would grow exponentially. You would see a curve going up. On this problem, B, it says the population of deer was low in 1920, then peaked in 1940, went down again in 1960, but peaked again in 1995. Well, it sounds like there's two peaks and a valley in this, so that would be a fourth power equation if you graph this. Peak was low in 1920, then it peaked in 1940, went down until 1960, then went back up again and then expected to decrease for the next couple of years. You get two peaks and one valley. That's a fourth power equation. The percent of people that get colds in the winter months on this, we're here assume that the growth will level off. Well, that would be logistic. Okay, logistic growth levels off. Remember, has a horizontal aspect to it. We did not have a choice of rational function in here. D, the amount of time spent watching TV is high for children, then decreases, and then viewing increases again. So that gives you a sort of a parabola-looking shape, and that would be quadratic. On E, it says trees start to grow rather quickly, but as time goes on, their growth starts to slow up. So slow up growth could be logarithmic or power, but power wasn't a choice on this, so logarithmic would be the choice on this function. And I think that's about it. Other things you should know is the shape of exponential growth, exponential decay. Power function is the best one-term function that describes a set of data. I think that's really about everything on this, but you should review the shapes of these curves, peaks and valleys with your cubics and fourth power and quadratics. Linear is growing by the same amount. Exponential is growing or decaying by the same percentage, and I see that's why banking problems are exponential, because you're getting a set interest rate, a percentage rate, so they're exponential. So we'll stop this video here, and that's